Welcome to Knowledge Drop, the podcast where we talk about science, technology, and engineering in a way that makes us laugh and smile. I'm Derek.
I'm Micah.
Not Hayden. Just kidding.
Yeah.
Hayden couldn't make it today, so I've got my good buddy here, Micah.
Yeah. So I went to school with Derek at community college.
That you did.
And we took a couple classes together and kind of shared some common interests with regards to NASA and space and SpaceX and just cool sciencey things. And that's kind of how we became friends. And I think through Derek, I also met Hayden. And the group of us with the engineering club, because Derek was your president of the engineering club. And
I did the engineering club for a little bit. It was kind of fun. For a little bit at least.
Derek actually arranged for us to go tour JPL. And here's the thing, I wasn't even in the engineering club. I was president of another club that was meeting at the exact same time, so I couldn't be a part of it. But because I had some conversations with Derek about just space in general, he actually reached out to me and I got to go on the trip. And I got to meet the Curiosity rover's twin, which is the identically made, except for it's not powered nuclearly, rover that they have, and they kind of have an obstacle course and actually use it to troubleshoot stuff. And it was really cool to see that. And,
I thought it was super cool that because we had one of the engineers on site kind of touring the facility, we got to actually walk where the rover drives. And got to go inside the building where it's parked and stuff like that. And that was
to stand 8 feet away from this thing.
It was so cool.
Us and a little ribbon between us and the rover, because I guess, if you touch it, static discharge could destroy a multi-million dollar piece of equipment. Yeah. Who cares? But yeah, and also because of Derek, there's a lot of that's a theme right now. The because of Derek, I got interested in what's called NCAS. That's the NASA Community College Aerospace Scholars Program. It's essentially an internship with NASA for community college students. However, you have to compete pretty fiercely to actually get your position in there. And he did it. Did Hayden do it too?
So unfortunately, Hayden didn't do it, but he does get an earful every once in a while from me telling him my experiences with it.
Yeah, so it's a really cool experience. Derek got to do it before I did, and then he told me about it, and then I got to do it. And
so where did you go again for this NCAS thing? You actually get to go to a NASA facility for a week and kind of do your thing there.
And it's a grueling week. You're there, and I went to Armstrong Flight Research Center. That's based at Edwards Air Force Base in the Mojave Desert in California.
Okay. Yeah. I remember that now.
The problem that we had is they have some areas that a lot of it is, I think the whole base is clearance is required. And then there's certain areas with secret and some areas I'm told with top secret clearance to get to.
That's cool.
And NASA has a little spot right in the middle of it. And if you don't know, the Mojave Desert is a gigantic flat lake bed, 60 miles long. And it's just a dried up salt lake. And that makes it really ideal for doing sonic boom testing and also experimental aircraft flight. So military does a lot of their stuff, but then NASA, what they're doing is they're testing sonic boom flight. The problem we had is because of the nature of the secrecy, we had to actually stay at a hotel that was almost an hour away from the building, which means we were getting up at 4 a.m. and we weren't going to sleep until after midnight every single day. And for a week, we were out, including the drive time, we were out doing stuff for probably 18 hours. And the worst part was also due to the secrecy, we were not allowed to leave the room that we were put in for the entire day unless they took us out. And there were some days where we didn't do any touring. So we were stuck in this tiny little room.
Dude, that's
for
nuts.
The whole day, and occasionally getting heart attacks from sonic booms. Car alarms were going off, and it seriously sounded like a car was crashing through the wall. It was nuts.
That's
But
cool
it was
though.
also the coolest experience ever because I got to hear and even more feel the sonic booms from those jets.
Yeah. No, that's
So it was
cool.
a cool experience.
It's very different from my experience. So I went to Ames in Northern California. It's right outside of San Francisco. So it's like the weather's beautiful. Our hotel was like 10 minutes away from like the Tesla factory,
God,
and it was something else. It was really cool. I could never live there just because it's stupid expensive, but
yeah.
it was cool to visit.
Ames is where they have the wind tunnels, right?
Yeah, yeah. So
Ames.
they,
So another thing is you're assigned a mentor for the NCAS. Is that what happened for you too? Did you get
yep.
like, okay, yeah. So you're assigned into teams and your team has a mentor. My mentor actually runs all of the the wind tunnels at Ames. I don't
What?
know if you met
Dude,
him.
that's cool.
Did you meet Kurt Long at all?
Uh-uh.
Because half his time is spent at Ames and the other half is spent at Armstrong. He actually, fun fact about this guy, he
Ooh, you're
if
alluding
you've
to
ever
something.
watched Mythbusters, anytime they had to go use a wind tunnel for an experiment, Kurt Long was there in the show, controlling the air tunnel. Like he was the one in charge of doing the whole thing.
Dude,
So
so
he was in multiple, like probably I think a dozen episodes of Mythbusters.
did you shake his hand?
Yeah, I have a picture
So
with him.
so you basically just shook the hand of Adam Savage and
You know, what is it? Today is Thursday. On Sunday, he had Adam Savage actually has a meet and greet via Zoom.
I know.
I
The did you sign up?
I was this close. It's $100 for 2 minutes.
I
Like that's
know, I
totally
know.
worth it in my book. I have a signed copy of his book right here.
Oh, that
Like
book is so good.
so good.
So what's funny is I talked about this last week, but I made this giant model rocket of Omega from my internship, and I used some material from Adam Savage's tested website. And so I
Nice.
tagged Adam Savage and he retweeted my
No
project.
way. That's
Yeah.
so cool.
Yeah.
Dude,
So that was really
that's
exciting.
awesome. That's like as close as I would ever get to meeting him probably,
Hey,
if that.
we'll have to plan another road trip.
Yeah,
And
man.
we'll go through JPL and then we'll go up to San Francisco and go to, they're
Dude.
calling it Silicon.
Yeah.
It's like Comic Con, but
Silicon.
in Silicon
Yeah.
Valley.
And probably
Um,
more techie based.
yeah, yeah, totally. But Adam Savage is apparently like one of the board of directors for
Yeah,
Silicon.
because Tested is like fully immersed in silicon.
Oh yeah, those guys
Like
are
all the Tested guys are a part of it.
absolutely, yeah.
Yeah. You know, fun thing to point out is the the, the excitement that Derek and I have about science. Like Adam Savage had that, and he back in like 2003 when Mythbusters started to air, because of that excitement, that's where that was born in me, was through that
Oh
TV
really?
show.
That's
Yeah.
awesome.
So like there's definitely room to be excited about science. It's not just for, you know, like your serious professors who like are super, super smart. Like anyone can get involved with science, and like it's meant for it. By definition, science is meant for everyone because you can't avoid it. So why
Yeah.
not just embrace it?
Yeah. No, I agree. Well, I feel like we've gotten a good chance to get to know Micah. So welcome to Knowledge Drop.
Thank you. Glad to be here.
Yeah, we're glad to have you. Now we're gonna move into our fun fact segment. So just as a question, because it will kind of lead into my fun facts, you hear a lot about like climate change and like how we're trying to avoid the Earth's temperature going up by 2 degrees Celsius. What does that mean? Like, just if do you know anything about that?
As far as like what causes it or what the repercussions are of it happening.
So we're going to talk about the repercussions, but like, what does that mean? Like, the surface of is it the surface of the Earth? Is it the ocean?
Oh,
Like, what
oh.
is 2 degrees?
So
What
two
does that
degrees.
mean? Where
Um,
does that number come from? That kind of stuff.
so I'll preface with I am absolutely by no means an expert in this field. So this is just
I don't
I'm
claim to be
like
one either. To be clear.
okay. I'll represent all the laymen out there. So My understanding is that the 2 degrees largely refers to the temperature, the average temperature of the ocean, um, because that's kind of where a lot of the measurement is taken. It seems to be more consistent, because you can measure the water in California, and if you're at the same latitude, you can measure the water on the other side of the Earth, and it should be roughly the same temperature. Um, so it seems to be a little more consistent for testing purposes.
So it is actually you're right, it's the average global temperature measurement, but it's not just the ocean. You'd make a good point though that it is more consistent in the ocean because the earth is 70%, like the surface is 70% ocean, so it makes sense that it would be mostly ocean temperatures, but it is the combined land, ocean, and ice temperatures.
Ice too. Okay.
Yeah, I thought that was interesting, so I wanted it to be a fun
Because
fact.
all of the and that's really important because all of the ice caps are fresh water, and it's harder to keep like fresh water. What is more, isn't it more susceptible to absorbing the energy? Like freshwater ice will melt. I don't know. This isn't a sign. This isn't a claim I'm making. I'm asking.
I
I
I
thought I heard that
honestly
somewhere.
I would have to look that up because I don't know about that.
Okay.
But yeah, so and the 2 degrees kind of comes from when you can go to Antarctica or any of the caps, they take measurements of the ice and they can see the air bubbles inside of the ice throughout time.
Hmm.
And so they're able to measure kind of how much CO2 is in there, and then from there they can kind of say like the temperature of the earth was kind of fluctuating like this in the past. And so they've built this model that's kind of showing there's a pattern to the earth's temperature. So it gets really really hot, the ice melts because there's more water covering the earth, more light is reflected into space, and so the earth gets cooler, the water freezes, and then the temperature, like it just kind of goes through those cycles of like ice age, warming up too much, melting, ice age. Does that make sense?
Yeah, yeah. And now that you brought up the measuring of the carbon dioxide, um, there's actually you can pull up on, I think, the NOAA. They have a present time update of the current count in parts per million of CO2, and it's actually significantly higher than what, like if you were to go back 200 years before now and take that number, it would have been between, I think the number was between like 180 and 220 parts per million, was consistent for the last like 60,000 years. But
Mm-hmm.
the last 200 years, we're now at like 420 or so.
Yeah, it's funny. That's one of the things we'll talk about is I
Okay.
have so NASA is the one that kind of brings all that data together, and they have like a real time graph showing you, hey, this is what the levels are
Yeah.
doing, and
Sorry to steal
they
your thunder on that. The only
no
reason I bring it
worries.
up is because I actually started writing a report on that exact thing 2 days ago.
Oh, cool. And it's funny. So you mentioned this before we started recording, but NASA actually, the data they have starts in like 1880. And so
Okay.
like that's how long they've been recording, is 1880 to like 2019 is all the data that they have.
Yeah. As far as like collected at the time,
Yes, this is like
without
data
like
that's been
looking back
collected.
into,
Yeah.
yeah.
Without like relying on other means of collecting this
Mhm.
data. So like going into ice and like getting the little bubbles and testing for
Yeah.
CO2, that's a different study
It's
per se.
reliable, but not as precise as far
Correct.
as the
Yeah.
dating.
Yeah.
Gotcha.
And so I actually haven't introduced the topic. We are going to be talking about terraforming. And, we hear a lot about terraforming Mars because, you know, our main man, Elon Musk, is going to go and retire there apparently. And
I'll go with
he,
them.
yeah, hey, it'll be really cool. I'd like to visit, but probably not stay for very long. Um, but yeah, we're going to talk about like why terraform, what goes into it, what kind of projects would that take, and like should we actually terraform at all? And so those are some of the
Awesome.
questions we're going to talk about. But before we talk about Mars, I actually want to talk about terraforming Earth. So the fun fact kind of clued you guys in on the problem that we're facing. Um, in the Industrial Revolution, we started burning fossil fuels, and this put CO2 into the air, which is one of the reasons the Earth is heating up so much, and that's why we're worried about this 2-degree change. Because if the entire surface of the Earth changes by like 2 degrees, it's going to have some really bad effects on humans, because most of us live on the coastline, not in Arizona, but a lot of, like, Los Angeles and New York are one of the biggest cities in the world, and definitely in the United States, and they're right on the coast. And so like it's something we need to be watchful of, because if we melt, the ice caps in those cities are going to be uninhabitable. Yeah. And like Micah mentioned before, I have a link if anyone wants to kind of follow up on anything we say today. I have links for everything that I read about and where was pulling this information. But 1884 to 2019 is when NASA, like, this is their data that you can pull the graph from and see like real time. And yeah, the last time, and the reason we picked 2 degrees is the last time there was a like degree change of that magnitude, it caused a large part of North America to have like an ice age, like thousands and thousands of pounds of ice everywhere. And so it's like, whether or not you believe in climate change, you can agree that, like, I don't know what you've seen, Micah, but like the consequences of our actions on the environment are coming back to
Yeah.
hurt us.
Yeah. And sorry if you're going to be saying this later, but
No, go ahead.
if you look at those graphs that NASA has, if you look at the graphs about when ice ages occurred, it seems like most of the talk right now is around global warming. Well, then why are we concerned about an ice age then? Well, if you look at them, then you'll see that right immediately before there's an ice age is when the temperature was climbing and climbing and climbing, and then abruptly fell very, very far, like super cold. So I don't know why that is. I haven't looked that up, but the trend has been that things heat up before they get very cold. And when it gets very cold, it happens fast.
Yeah, so we'll talk about some, they're called Geo Engineering Projects, and these are things that we're contemplating doing here on Earth to kind of combat this climate change, global warming problem that we're having. And so just a question for Micah, just to see, like, discussion wise, I've kind of always felt that as humankind progresses, we are moving more towards being masters of what's around us. Long time ago, we found that rocks could help us do things, and so we used rocks, and we progressed to metals and wood and like all of these different materials, and we used our environment to help us control what was around us. And I feel like at this point we're so dependent on the biggest, like, component of this domain that we have here on Earth of Mother Nature. Like, we see every year that hundreds of thousands of people are displaced by hurricanes and earthquakes and floods and famine, and it's because of the weather, right?
Yeah. For a lot of the cases, yeah, weather, even if right now, as we speak, there's a hurricane passing over Louisiana. And it, according to the reports, is one of the most powerful in recorded history, is at least for that region. I think it was a Cat 4 last I saw. And it's not a coincidence that we're having more frequent bad storms as well as more intense storms.
Yeah, absolutely. And I think it's because we're not fixing the problem. The temperature is still going up, and I think a theory that I've heard is that Mother Nature is trying to correct itself. It's trying to correct this problem of heat. And
Yeah. I've heard that too.
And so do you think that like humanity is like no matter what happens, if it's an ice age or if like all of our coastal cities flood, we're going to be able to make it work? Or do you think that we are kind of walking on this razor's edge of like some really bad things could happen and it's going to be very detrimental to us as a species?
Well, my personal unprofessional opinion is that the way I see it is, if you look at all of the past events, all of the past ice ages, life has made it through. Sometimes barely, but it's made it through. So I have no doubt that like we're going to make it through. Like I personally don't believe humanity is about to be extinct, but I do think that unless we change things up, then even within the next couple 100 years or even sooner, there's going to be a significant reduction in the amount of people who walk the face of the earth.
Mm-hmm.
And the earth will not be like it is today.
Yeah. I think so in my research it was kind of interesting, but they said that humans have been geoengineering ever since we created the first factory and started burning fossil fuels. We've changed the earth so much that now that it's kind of on this path, we're afraid of where it's leading, and we're trying to change that path so that we can continue to live as we have been. But I don't think we can live as we have been. We need to be better. Um, and if you think about it, we're so reliant on fossil fuels that, like, let's say tomorrow we run out. Like, how far back in history is that going to set us? You know what I mean?
Yeah. Yeah, because I mean, everything we have today, like my phone in my pocket, is relied. If you follow the steps back upon mining the resources, if you don't have the people to even do that first step, you're not going to be able to do that last step. So there's going to be a reduction in what we can do because there's going to be a reduction in what we have available to do.
Mm-hmm. No, absolutely. Like all those mining um, companies and the equipment, the people that you mentioned, like without fossil fuels, the trucks won't run, the
Right.
generators won't run. Like it's going to be total chaos.
And it's not going to just trickle down. It's going to be a tidal wave across everything. Like when was the last time you left your house without your phone, without your car, without like a credit or debit card that had a chip in it, or and clothes that you made yourself, that you crafted out of material that you grew yourself or harvested yourself and went hunting? And like, see, these are kind of things that are affected because how much stuff is imported into the United States.
Mm-hmm. No, I was just
You,
about to
you
say,
won't be
like,
able to import it anymore.
yeah, all the food that we have is like totally imported from other places. How's that going to get here without fossil fuels?
Yeah.
And so,
And
yeah, go ahead.
and then also with change in climate, it's also going to be the change, maybe reduction or just I don't know what, of resources available to things like livestock, which
Mm-hmm.
provide milk, or you have chickens that provide eggs and meat. And like without all of those things, like there's going to be a significant reduction in food, and people are going to have to either quickly use the ingenuity we've used so long to get us to where we are to figure out how to be more self-reliant, or we're going to die.
Yeah.
It's going to become survival of the fittest.
Well, and I don't think it's just about self-reliance either. I think it's mostly about like we need to take care of what's around us, not just charge in and destroy it and use
Yeah.
it for our gain. Like um we're learning that like the the things here on earth are like coal and fossil fuels, and like these things are not renewable. They're
No.
not things that are going to last us forever. But not only are they non-renewable, but they hurt us. They go up into the atmosphere and they make things hotter. They make places like Arizona even worse to live in.
It's already been pretty bad.
Yeah. Something that I learned from, I don't know if you watch Mark Rober on
Yeah.
YouTube, but like he did a video on fake meat, like a
I haven't seen that
substitute.
one.
So the title of the video I think is like, I fed Bill Gates a fake burger.
Okay, I did see that one.
But he talks about how it's more beneficial to farmers in South America to burn the rainforest for livestock than it is to like leave the forest there. And
Yeah.
he says it's a double gut punch because not only are we losing like the Amazon rainforest, like all of that carbon, CO2, like all that was captured and it was giving us oxygen to live. But now the cows that roam that, um, they fart and burp and create
Yeah.
even more greenhouse gases.
And not to mention the burning of the forests themselves.
Yeah, yeah, no, absolutely. So it's interesting. So we need to move beyond destruction and like building things. Like we need to live with the future in mind instead of like
Yeah.
this is going to benefit me here now. I need to think of what are my actions going to do for the future. And so, yeah, now that we've gotten all the doom and gloom kind of out of the way, we want to, because we're science guys, we're going to geek out over the science of terraforming. And I have this really good quote of, we talk about terraforming Mars very easily. And I'd like to just address why terraforming Mars is so easily and widely accepted versus terraforming on Earth, because it's very, very controversial. There's some like rogue environmentalist groups that have done like projects. There was one in Canada a few years ago that they did, and I'll talk about it later, but they did it and it like brought down like the wrath of the UN, as powerful as the wrath of the UN is. They were super upset about it. And so,
Wow.
so this quote comes from Chris McKay, and he's a scientist. He kind of started this conversation of terraforming, and he says there's so many of us, and Earth is so delicately interwoven. When I'm talking to students, I draw the analogy between humans on Earth and a bowl in a china shop. No matter what we do, we're breaking something. But on Mars, we're like a bowl in an empty field. Anything the bowl leaves behind is positive. It's a whole different paradigm. And I really like that because yes, Earth is a super complex system, and we don't really know the effects of changing one part of that system is going to have on other parts. And we'll talk more about those specific changes later. But I just thought that was really interesting, and I want people to know about that. I don't know if you have any thoughts on that, Micah.
No, I think that's a pretty cool quote, because it's like here on Earth, I mean, the word terraform in its own means to make like Earth, right? Isn't
Yeah.
that the
Yep.
so for Earth to already have to be the terraformed item, like there's not much left to make it more like Earth. You can only make it worse. I mean, you can make it better, but to make it more Earth-like is like you can't really do that because it already is Earth. So we can do more damage here than we can good, compared to somewhere else. Like there's not much we can really damage to begin with.
Yeah. No, that's totally it. And like we
At
were
least
talking
we'll have
about
more
before.
time to figure it out.
Yeah. Because the time scale for terraforming Mars is like, so this same Chris McKay, he says if you had 100% efficiency and 100% efficiency of turning water into oxygen and CO2 and like all these different 100% efficiencies, which to be clear is impossible, it would take 17 years to totally terraform Mars.
Wow.
Like 100% efficiency in every system you could have. But we know
That's a
that's
lot.
impossible. Yeah.
It's a lot sooner than I thought it would be.
No, I was surprised too.
To
But he was saying in like more realistic terms of efficiency and stuff like that, it would take anywhere from like hundreds of years to hundreds of thousands of years.
wow.
And so, yeah.
Man. To put it out there, I am a skeptic of terraforming. I'd say it's a healthy skepticism. I'm not like in denial of the possibility, but I do have some things that I feel I have questions. So
That's good.
hopefully
That's good.
throughout this, maybe you might have some answers.
Yeah, let's hope so. So right now, the next couple things we'll talk about, these are ideas for what we could do here on Earth to kind of combat the climate change. Because um, like I mentioned before, we should try to think more of the future and what we're trying to leave for future generations, and not just what's going to benefit is us here now. And so we need to start trying to understand our planet and trying to understand how we can like tweak the different variables that will make it more livable for more people. Because with this global climate change thing that's happening, if I could show you guys the map that NASA has, there's a giant red spot over like kind of the Middle East / Eastern Europe area. And these are, this area is where the hottest, how do I say this? So like the average temperature of the earth is increasing the most here. Does that make sense?
Yeah. Yeah.
And so like it's already kind of a desert there already, but there are millions and millions of people living there that it will soon not be habitable. Like they won't be able to
Wow.
live there at all because it's getting so hot that the plants and animals can't live there anymore. And so these are ideas that we could implement to help existence on Earth for humans, plants, and animals to be better. Because the hotter it gets, the more plants and animals go extinct. Like there are hundreds of species of plants and animals and insects and stuff that are going extinct right now. And
Yeah.
so it's, yeah. So Micah, I'm gonna read off some of these ideas, and I just kind of want to hear your thoughts, and
Okay.
we'll talk about them and see how cool or not cool or whatever they are.
All right.
So the first one is using nanotechnology to control weather. And the way that this would work is they would be balloons that are carrying a tiny mirror that would reflect the sunlight either back out into space or sideways. Does that make sense?
Yeah. So this would be on Mars or Earth?
Earth, sorry. Yeah,
Earth.
these are
Okay.
all
Okay.
exclusively to Earth ideas.
Okay. How big are these mirrors?
They're tiny. They're nano-sized. But if there's
Oh, I see.
like if we
Okay.
have a giant cloud of them up in the upper atmosphere, we don't have to deflect a lot of sunlight, but just enough so that it's not, so the temperature doesn't keep increasing. Does that make
Okay.
sense?
Yeah. So how would that affect things like air travel and safety? Because if you can't see them and say a helicopter goes up, and like how high are these things?
So airplanes only fly like at, I don't know, like 20 to 50,000 feet. Like
I think, yeah.
those are including jets, like fighter jets and stuff. And so these are going to be like, I think it's not the stratosphere.
The U-2 jet actually flew at 69,000 feet.
Well, dang, I
But
guess we'll have
I
to.
don't think there's like two of them in existence. I don't know if you have to worry
Yeah,
too much about it.
that's true. Well, I don't have the exact altitude, but these would be high enough to where it wouldn't affect any kind of air
Okay.
travel. And they're so small that I don't know if it would really cause, like, yeah, it wouldn't be that great to fly into a cloud of these, but I don't know if it would like bring the plane down.
So you said there balloons would hold them up? Like, would it be
Yeah,
like
so
a big balloon holding the pack of them, or like a microscopic nano
yeah, so
balloon?
these are nano devices, and so they're
So each
tiny.
one is okay.
And so what they're saying is if we need to really bring temperatures down, we could turn the mirrors to reflect the sunlight back into space. But if we want to only, there, the different spectrums of light, there's long wavelengths of light that hit us.
Mm-hmm.
You could keep all the sunlight that is coming to Earth, but you could deflect the long wave harmful radiation sideways back like into space, but like in a roundabout way. Does that make sense?
Mm-hmm.
So now that you're still getting the same amount of sunlight, but you're not getting those harmful, like really intense sun radiation.
So you mean like certain
Like
like
really intense
UV
UV.
light?
Yeah.
So
Yeah.
isn't that shorter wavelength
Ultraviolet.
or
Oh, maybe I'm thinking of
higher
infrared.
frequency?
Yeah, I think I'm
Oh,
thinking of
infrared.
infrared.
Okay,
Yeah.
because that's the heat. Infrared
Yes.
is what heats things up.
Yeah. So we
Gotcha.
wouldn't have to compromise on light, but we could divert the heat away.
Okay. Yeah, I think that'd be pretty cool. How would we control them And how would they be able to orient themselves?
Well, I think there'd have to be like, I think the easiest way to control them would just have them regulate themselves. And like, if the temperature gets above this way, the nanotechnology could just turn the mirror itself. You
Okay.
know what I mean?
Yeah. They could use, you know, like those, the bathrooms that have the frosty glass when you flip the switch and then it turns clear when you flip it back.
Yeah, yeah,
Just
yeah.
have little things like that where they just,
Well, so the other thing too that this is related to, that you're talking about kind of too, is people have been saying we should put giant solar glass mirrors in space to kind of cover the Earth and only allow a certain amount of light in.
huh,
Um,
like an
that
orbit.
was Yeah, so in it's called Lagrange points, that like
Oh,
the
okay.
gravity of Earth and the sun would be balanced. And so if you build like a giant solar glass there or a bunch of little solar glasses, you could block a certain amount of light and then thereby lowering the temperature of the Earth. Um, but if you go to a YouTube channel called Answers with Joe, he does a really good video on explaining why
Okay.
that's so beyond anything we
Because
could do as humans.
the further out away from Earth you get, then the bigger the shadow it can cast. Right? Is that what you're saying? Like it'd be like pretty far out there between
Well,
us and
it doesn't have it. It's not so much about how far away it would have to be to cast a shadow. It's that we want those solar glass things to be stable orbits. And so there's a point between the Earth and the sun where they would be relatively stable because the gravity of the Earth and the sun is pulling on those glasses equally.
okay, gotcha.
And so that's the point that they would put those mirrors or glass things.
Out of curiosity, how do you happen to know that distance from Earth?
There's so many different Lagrange points. I don't know, because there's a Lagrange point for like between the Earth and the Moon. There's one between the Earth and the
Oh
Sun.
yeah, because you'd have to take that into account too as
Yeah.
the moon orbits, huh?
Yep. And then not to mention like other planets that are going to be going by, like Jupiter and the Sun have huge gravitational poles that are going to influence that Lagrange point. So like they're not totally stable, but they're stable, more stable than if we would have to like have thrusters and stuff to correct them all the time.
Okay.
So that's
Wow.
one idea. And the reason I brought up the solar mirror part is because that's really expensive and we don't really have a great way of getting into space yet. Like, yeah, reusable rockets are great, but transporting millions of like
Yeah.
fairing sized mirrors into space is it's not going to
It'd
happen.
have to be quite the umbrella.
If I Yeah, exactly. If I remember the math right that Answers with Joe's does, he says you if you wanted to do this project in 10 years, you'd have to launch a rocket, like one of SpaceX's biggest rockets. You'd have to launch that rocket every like 30 seconds for 10
Dang.
years.
I don't think they're quite at that kind of
Yeah.
turnaround.
Yeah, I don't think so either, but so because we don't have to go into space, these would just be in the upper atmosphere with balloons and I don't know,
Okay.
it's a lot more feasible.
Yeah, it seems like it.
So that's one way. And
Okay.
to be clear, when we block the sunlight doesn't have a chance to get to Earth. And because the sunlight and the heat isn't reaching Earth, the Earth doesn't get as hot. And that's the whole goal is we want to cool the Earth down, but not
Right.
cool it down to an ice age level. So we're kind of like trying to balance the equation. Right now it's super unbalanced and it's like this thermal runaway system that we have going.
Cool. Yeah. What
Um,
about are you actually no what's your next one? How about that? Because
yeah,
I feel like I'm about to ask what
I'm sure you'll be familiar with a few of these. The next one that I want to talk about is there are these boats that this concept company has to make that will pump seawater. Or sorry, that's a different one. This one is they will pump seawater to deserts like the outback of Australia and the Mojave Desert and the Sahara Desert. In those deserts will be solar powered desalination plants, and these will grow crops in the desert.
oh,
And because the crops, like the greenery, will absorb more CO2 and will like absorb the sunlight and heat more than sand will, it will lower the temperature of the earth. But now you're also providing crops for places that you didn't think could grow crops.
wow, that sounds
Um,
ambitious.
It
I
is
think even
very
more so than
ambitious.
the nanotechnology.
Yeah.
Although that's a good way to get a lot of food too out of it.
So that's kind of why I like it, is you're not only like solving a global like warming issue, but we're gonna have a food problem if we don't
Yeah.
control the global warming, because a lot of places that we're trying to grow food won't be able to grow food. The other cool part about this system is if you can get it going, it's self-reinforcing, meaning that like the crops and the greenery will just continue growing. If you keep supplying the water, it'll just continually grow and get larger and more green.
Yeah.
Now, I did read about a downside of this, and this is about one of those. So just imagine you have like a switchboard with 100 switches, and you flip one switch, it's going to automatically mess with a bunch of other switches. Now, by pumping seawater and doing this whole desalination crop thing in the desert, especially in the Sahara Desert in Africa, the rainforests of South America rely on dust coming from Africa coming to fertilize the rainforest. And so
Okay.
by putting greenery there and crops there, that dust won't come to fertilize the rainforest in South America.
Put it in Arizona. I'll welcome that.
Yeah. The other thing that is kind of this is just for Africa. I don't know about Australia, but by having all this greenery, there is locust problems that like
Yeah.
there would be a like biblical level event of locusts coming to devour these crops. And
Okay,
so
don't
that
put it
would
in Arizona.
yeah,
Keep it away from me.
yeah. So that one was cool. I don't know if like you
Yeah.
said it's kind of a little bit more reaching than the nanotechnology one. Why did you say that?
However, it would open up a lot more jobs
Agreed.
because I mean, it gives a lot more opportunity to farmers. One of the problems we have right now, especially in Arizona, is a lot of farmland in like the valley here in Phoenix.
Mm-hmm.
But because of the expansion, um, so when we get our water, we get it from the Colorado River, and it's allocated throughout the valley, and somewhere around like 70% of the water that the entire valley uses is for agriculture. But what they can do is if they get rid of a farm, they can reduce the amount of water usage that, is required and put houses there instead, because the amount of houses that would cover the same amount of land as a farm use significantly less water,
Yep.
because we're facing a potential water shortage. So they're trying to reduce that. So
Yeah.
what we're doing in turn is now we're reducing the number of farms that we have. So we're adding people and reducing food
It seems super
already as we
backwards to
go.
me.
It does, but I mean, solve one problem by creating another,
Yeah,
but it's not as
it's just like I'm
imminent,
saying, you flip one switch and it automatically
Yeah.
flips a bunch of other
But
switches you weren't intending.
which one's the more immediate one? It's cheaper to import food than it is to import water.
Yeah, it's true.
So now we get most of our food elsewhere.
Yeah.
But what happens when there
Um,
isn't an elsewhere to get food?
yeah, no, so that brings up a fun another fun fact.
Ooh.
There's a company just north of Phoenix in Scottsdale. They're working on it's called vertical farming, and I would kill to like go work there or
It's
like
like
have an
Kimball
internship.
Musk.
Yeah, yeah. So like Kimball Musk is doing like shipping container kind of stuff.
Yeah.
And he's still doing vertical, but imagine so the guys in Scottsdale, these guys are like they're in a warehouse and they're these like I don't know, they're like 2 maybe 3 feet in diameter, except the cylinder goes like 50 or 60 feet in the air.
Oh man.
And so and there's no dirt. There's
Oh,
no
so
soil. It's a hydroponics.
hydroponics.
Yeah, it's
Yeah.
hydroponics. And so you grow like so in the warehouse they're growing all these kale and spinach and all these greenery, all these green plants, and they're like we're using like a tenth of the water that we would use for regular irrigation. We're growing like 4 times as much food per square foot as anybody else could possibly do. And I'm just like that's it, that's
Yeah.
the answer.
Well, and I'll tell you, I have a couple like miniature hydroponic gardens myself, and man, do those things grow fast. Like we planted a lot of basil,
Uh-huh.
and within like 10 days, we were already harvesting, and we couldn't harvest fast enough. Like we
Dude,
were eating, like specifically eating Italian food most nights because we needed to use up the basil and we couldn't eat it quick enough.
that's funny. So
Um,
my mom, she grows it and she freezes all of the extra basil and like
we had
peppers
to
and
dehydrate
stuff.
it. We started to dehydrate, like
Oh
crush it,
yeah, that's
we got a
awesome.
food dehydrator and then took all
Um,
the moisture out.
we'll have to come. You'll have to come on another episode that I'm planning on doing. So Hayden and I, we started talking about how like the idea of grass. Like when we buy houses in the future, the idea of grass, like that hurts my brain a little bit because it doesn't make sense to me. It just looks nice. It's a draw on my water resources. It's taking up square footage that could be used
Hmm.
for much more useful things.
It
And
keeps
so
things
like,
cool. And it's soft. That's like
yeah,
if you walk on it, you're
it's
not going to melt.
also
But
true.
yeah, that's
But we were just talking
xeriscaping.
about how I wanted to take like my plot of land that's like, I don't know, going to be like a quarter acre or eighth acre, whatever they're doing now, and build like the most efficient automated system possible. And I already have like this list of all of the things that I want to do, and
Nice.
I want to like workshop it with Hayden for a podcast episode. So we'll have to make sure you're
Yeah,
invited because
totally. I have a same kind of, not maybe probably as extensive as yours, but I have a list in the same way that like my dream property and self sustainability. I'm a huge um proponent for hydroponics and aquaponics.
oh yeah,
Like
absolutely,
totally support that.
yeah,
I would love to get like I don't know, like an associate's degree in sustainable agriculture, like
oh yeah.
just so that in the future, because that's gonna be a really good survival skill when the time
Well,
comes.
I was telling Hayden about this guy in California. He has a big tank of tilapia fish, and the fish are fed off of algae that he grows in his garage, and the fish poop feeds his plants, and the
Mhm.
plants um,
Feed the
feed the fish
algae,
or
or the
feed the
plants
algae. Yeah,
create
sorry.
the algae.
So he's almost got a completely closed loop,
Yeah, that's
and
aquaponics. Yeah,
what he's doing is he's selling the tilapia and he's selling the food that he doesn't eat. He sells to a restaurant he has a contract with, and he
that's
makes
crazy.
$100,000 a year doing
See,
this. Completely automated system, almost completely
I would
automated.
totally do that, but like hydroponics already is hard. Aquaponics is
Yes,
even more difficult because now you have fish that you have to keep alive.
yes, I
But
agree with you.
like if you know how to breed the fish, then when the fish is big enough, you just eat the fish, and
Yep.
then the little ones kind of just starts a cycle. But there's so many things relying, like if one
Like
little
yeah,
step fails, all of them will
yeah,
fail.
like the level of nitrogen in the water and oxygen and like
So
the
specific.
pH and yeah. But
It's an incredibly delicate system, but it's also like it could be the thing that like
if you could
provides
automate
us
it,
so much
yeah,
food,
we should see if we can't
healthy food too.
get a company, me and you and Hayden will
Let's do it.
automate a whole system and make
Well,
people
the three of us
money.
will call it omega 3 because of that
Yeah.
fish.
Yeah.
Those omega 3s.
Yeah.
We get salmon instead.
Oh, salmon. Um yeah, that was a great tangent.
Yeah, I love that one.
So circling back to terraforming projects, this one's a little ludicrous in my opinion, but I still wanted to talk about it because it's kind of funny to think about. So do you know where the Strait of Gibraltar is?
No, I don't.
So the Strait of Gibraltar is that tiny, tiny little piece of ocean that connects the Atlantic Ocean to the Mediterranean Sea or ocean.
Okay.
And it's kind of between Spain and Morocco.
Oh, okay.
So it's
Okay.
tiny. They almost connect. They almost touch, and it's called the Strait of Gibraltar.
Yeah, because I thought there was an opening, wasn't there? Or it's
There is an opening.
okay,
It's
so
the
it's not
way
all the
that
way.
water. Yeah, it's the way that water comes into the Mediterranean Sea.
Okay.
So this idea that these guys are saying we should do is they're saying we should not let water flow through the Strait of Gibraltar. We should dam it like a hydroelectric dam, and then let the like divert almost the water that would come through there to the Sahara Desert and create this massive like Saharan lake instead of desert. And so the water level of the Mediterranean Sea would go down, but then because you can mess with the levels of the Saharan lake that you're making and the Mediterranean Sea and the Atlantic Ocean, because you can kind of mess with those levels, you have hydroelectric power forever.
Man,
But then you're also creating more surface area of the earth, it's water, so that it reflects more light and heat into space and doesn't absorb it.
that would recreate Atlantis, you know, out in
that,
it,
that's
have you
funny you mentioned
seen
that. They
have you
talk
seen
about,
that?
yeah. They mentioned they would call, because there would be an island in the middle of the Saharan, just the way that the elevations work. There would be an island in the middle of this lake, and they were thinking about calling it Atlantis.
Well, you know, in the middle of the Sahara, or I guess mostly west, I think it's like, oh gosh, it's probably a good 150 miles away from like the western part of Africa, but it's huge area of land. And I think either it was Plato or Socrates had written about this place. He had written about Atlantis and had said, like, kind of gave the design, like what it looked like. It was like rings, like it was an island and then a ring of water, then another ring of land, and another ring of water, and then land. And there were mountains in a certain position. And on the north side of it, well, if you actually pull up Google Maps you can zoom in on this one area. It's called the Eye of Africa, but it's in the exact same shape that was described in his
Dude,
notes. And there's a mountain range right above it.
I've never heard of that before. That's really
Pull
cool.
it up. It's weird because there's no way that like nature could have created this, because it's a perfect like bullseye kind of shape. And the land goes like this.
Could
So
it
there's
could it
like
be like
raised
an
land and
impact, like a meteor impact? Because I know
no,
that,
not the way it's designed,
really,
because
that's cool.
it's
That's
you
even
got to
cooler.
raise land and then it goes down and there's a ring. So you have like a circle of land and then a ring of like recessed land.
Uh
Now
huh.
you have another ring of raised land, then another ring of recessed land, and then another ring of raised land as it goes out. And what he had written is that they actually diverted the water from, I think it was from the Atlantic Ocean, the whole distance, and that's how they filled it with water.
Dude, that's super
But look it
cool.
up. That's one of, I mean, I don't think it's a confirmed thing, but it's like that's what we know about what possibly was Atlantis. Like that could have been what it
Hmm.
was, because the areas are big enough. You could fit ships in the little rings.
Oh
It's
man.
weird. Like pull it up on Google Maps. Like it's
Yeah, I'll
weird.
have to look more into that this weekend.
So we might recreate it if we did that. Just put the
Yeah, we
water
would.
there.
Yeah, we'd have to name it Atlantis again.
And we have to. Atlantis
Um,
too.
yeah, Atlantis too. Um, so yeah, I thought that was an interesting idea. I don't know if, so one of the problems with all these terraforming projects on Earth is we will never, so all these are technically possible, right? Like we could make,
Theoretically.
yeah, we could do that. It's not out of the realm of possibility. Like physics allows these things to happen, but politically, absolutely impossible.
And economically.
Yeah, kind of.
I I mean, I think it would be on the order of trillions of dollars to execute any one of those.
True. But if we're able to take advantage of all of the resources, like if this is an emergency kind of thing and no one's like keeping track of debts and stuff, I feel like we might be able to do it.
Could use the
Plus, like,
wrath of the UN.
yeah, as powerful as it is. Um, so yeah, politically, these probably will never happen unless it's like a 2012 movie level of cooperation, but I doubt we'll ever be able to do that. So the next one, so this next project is actually happening in Switzerland, and
Really?
they're called carbon capture farms.
That was one of the ones I was going to ask about.
Oh, really?
That if we
Okay.
can remove the carbon,
Yeah. Do
the
you want to
carbon
talk about
dioxide.
it?
No, I don't know much about it. I was just
Oh,
going to ask
okay.
you if that
Okay.
was like one of the actual, a
So
feasible project.
yeah, so Bill Gates actually has kind of invested a little bit with this program because there's two parts to it. There's these. Well, I'll describe how they do it. So just imagine like hundreds of fans right next to each other, and they're all sucking in air. And what they're doing is they're pulling in the air and they're running it through a bunch of processes that are pulling the carbon off the CO2. So it's just oxygen, and they're letting the oxygen go, and they're having just this carbon. Or alternatively, they just take the CO2 and they just pressurize it. But the two things that they could do with the CO2 that they just pressurize with is they have been selling it to greenhouses. Sorry,
Okay.
my voice just cracked really weirdly. Um, they're selling it to greenhouses, and they're pumping CO2 into the greenhouses. And this is actually creating like a 20 or 30% increase in the size of the fruits or vegetables or whatever is being grown in the
Interesting.
greenhouses. So it's helping to grow food.
And forget about more food, just get bigger food.
Yeah, exactly. And then alternatively, if no one is buying this, because it's still expensive to buy carbon dioxide when you don't need to, you know what I mean?
Yeah.
So until it's like they're giving it away, no one's going to really do that. The alternative is to pump the CO2 down into naturally occurring caverns and caves in the earth, and like sequester it there. So just kind of keep it
Okay.
tucked away. Um, the, I think
That's
Iceland does a similar thing where they do geothermal, and all of the noxious gases that they release from geothermal, they capture and then they pump into volcanic rock that's porous, and then they cap the top, so it kind of sequesters it in this um, porous rock, and that's
so they're
kind of what
just
they would do.
creating the Chernobyl tomb thing, just over
Yeah,
again, covering up the
exactly,
plant, covering up the
exactly.
bad stuff. But that's actually, I feel like that's not too different than how nature, I guess, recycles the CO2,
Mm-hmm.
because the carbon dioxide in the air, correct me if I'm wrong, but I feel like this is what I've read, is it gets like dissolved into ocean waters and kind of makes its way down and then gets into the bedrock. And then that's how it is kind of pushed through again. And then over time, as the bedrock moves, then um,
It's
uh,
disturbed and it floats back
yeah.
to the surface.
But at that point, it's like, I can't remember what happens after. I just remember reading something about how, like, that's kind of how the oceans are a huge part in getting rid of carbon dioxide.
So it's funny, that's actually part of the next project that we'll talk about.
Oh,
That is like the
okay.
ocean floor is a big, like, basically battery for CO2. But yeah, it I like this one because it's mimicking nature. It's a
Yeah.
system that we know works. Like photosynthesis is what we're taught in grade school, that the plants, they take in CO2 and sunlight and they make sucrose and oxygen, and they don't need the oxygen, so they give it back to us. You know what I
Yeah.
mean? And so I like the idea of, if we were able to take these farms and like totally make them automated and solar powered or wind powered or whatever, such that we could just take the actual carbon off the CO2 and then use that carbon for something like carbon nanotubes or something, and build a space elevator, which is another episode.
Or build bricks and houses.
Yeah, or build bricks and houses, because carbon is a great insulator when it's
Yeah.
like in an ablative brick. Um, they use that for the bottom of some of the space shuttle, I think.
I thought they used
I
like
think,
some kind of silica.
yeah, maybe it is silica. I can't remember. I thought there's like a carbon sponge that's like
Well, it
ablative.
probably is a combination of multiple things.
Maybe, yeah, you're right. So yeah, anyway, that's why I kind of like it. So the next one is about the ocean, and this is the one that I mentioned before that some environmental group got in trouble from the UN for. So if you dump iron into the ocean, you're going to be giving a whole lot of food to algae, and what's going to happen is they call them algal blooms, where there's just this
Oh,
massive, huge
is that
increase of
when it turns
algae.
red?
Yes,
Yeah.
some algae turns red, but yes, you're
Okay.
right. And so what happens is all of these algae are going to feed off of the CO2, and this would increase the oxygen because they also take in CO2. And when they take in the CO2, the algae gets eaten by other organisms, and then those other organisms die. And then when they die, they sink to the bottom of the ocean. And that's kind of what you were saying, is there's all this CO2, there's all this carbon buildup on the bottom of the ocean because of all of the plants and all of the animals that have died or have been eaten and died and are piling up and creating this large deposit on the
Yeah.
ocean floor.
So it's like force feeding the circle of life.
Yeah, exactly. But yeah, the thing with this one though is we don't understand the consequences of what that would create. You know what I mean?
Ignorance is bliss. Let's just do it.
And yeah, so I don't really know much about the ocean. To be honest, I kind of have my head in the clouds / in space.
I think a
And
lot of
so,
people don't know a lot about the ocean.
I mean, one of the main arguments for NASA is why should we explore space when we haven't even completely discovered the ocean floor. So,
Yeah, we don't even have it mapped like entirely.
yeah.
That's
And
cool.
so, yeah, that's a cool project.
So couldn't it be something that could be like experimented with like on a smaller
like a
controlled
local regional
scale?
level. I'm
Yeah.
sure that would be possible, but you'd have to get clearance from the UN.
Yeah, just go to a country that isn't involved. Hey,
Well, so that's the
let's
thing is
try
like,
Cuba.
well, Canada loves this geoengineering. From what I've read, they love this geoengineering idea, and that's where this like dumping the iron in the ocean project was in Canada. It was in like Vancouver, British Columbia area, and so there was a group there. I think it was partially government funded, and they just dumped a whole bunch of iron into the ocean, created a giant algal bloom, and they got in huge trouble for it. And Canada's like, hey, what are you going to do about it? We
I
won't
guess
do
it
it.
already
Yeah, I
happened.
was like, I guess we'll never do it again. Ugh.
Wow.
But yeah.
I guess something that's so unproven, and I guess that is kind of a big deal.
Yeah. So, and then just kind of moving on to the next project. So the next one it's similar to the first one, but this one there are certain type of aerosols. Aerosol meaning like, the stuff that comes in like pressurized cans. There's certain aerosols that you can spray into the atmosphere that will block heat and light. And by doing that, you cool the earth.
Uh,
Like really simple.
wouldn't that kind of fall in the line of the conspiracy theories of
Chemtrails.
like, yes, because
Yes.
that's kind of how it would be done, partly, right?
I mean, I
Like,
guess
if you were to do it in a specific region, or would you just
I
deploy like those mosquito trucks that spray out?
honestly, I think it would be easier just to send like rockets and like use all of the
Oh,
missiles that are for defense, just load them up with this aerosol and then just put them up in the upper atmosphere. Cause then we don't have to worry about them
yeah.
like reacting with fuel and airline engines and stuff like that. But
Push down on the top piece to release the
yeah,
pressurize.
no, just put a zip tie on it and call it good. But yeah, this one though, they're really, there's a team, I think it's MIT. Let me check the link just so I don't flub let me see. Yes, I think it's MIT. MIT is actually performing an experiment with this idea like this month.
Oh,
They're not doing it in the atmosphere though. They're simulating the atmosphere in a chamber on like a campus or on a
okay.
company. But they're trying to see if we do this, what effects could happen. Like
Wow.
what are the other switches that could be flipped if we do this?
How do you test something like that on a small scale? Because don't you need like the height of the atmosphere to get that difference of pressure, like
Well,
life on the ground and versus up in the atmosphere?
we have pressure chambers that we can
Yeah, but
artificially.
wouldn't you want both at the same time to
Well,
see
that's the
how
thing
one
is
affects the
like,
other?
I think what they want to know is how long will these particles float
Oh,
at
okay.
that
Okay.
at that pressure at that level, and like what are the effects of like wind and things and temperature and things like that that would be on
Wow.
this aerosol. Because if these, like, let's just say at that temperature and at that altitude, the aerosol crystallizes and then just falls. and then like it could potentially, when it starts falling, it turns into liquid. It coalesces and turns into rain.
Then got a
And
chemical
then
rain.
yeah, then you have chemical rain. Like
Oh boy.
I don't know if that's possible, but I'm just saying like that could be an issue, and that's what I think they're trying to figure out.
Shouldn't you be on that team? Ideas like that.
No,
Then you call back.
I think I'm too, I can thank SpaceX for this, but I have a very low tolerance for like slow moving projects. Like
Yeah, I get that.
when that's one of the things that like, if I hear a project, I'm like, oh my gosh, that's so cool. Let's do it.
Well,
And
then you
then,
don't want to work for the government.
yeah, kind of, we'll see. But the downside is like, if I hear about a project and like, yeah, but we're going to do this in over the course of 20 years. And I'm like, 20 years, that's like half my career. I want to work on a lot of stuff. I don't want to just work on one thing for 20 years. So yeah. And so this is the last one for Earth terraforming. And we were talking a lot about this one before the podcast. So it's very cool. It's called cloud seeding, like seeds that you plant. And these are, just imagine a boat with these giant like smokestacks basically on top of them. And they're going to suck in spray ocean water, and they're going to spray it into the atmosphere to start like to seed clouds, to like start the formation of clouds. And because we're artificially creating more clouds than there would be, the clouds would reflect light and heat back into space.
Isn't that kind of along the lines of those government, the HARP project?
Tell me about that. I haven't heard about that at all.
Oh gosh, I think it's like in Alaska. It's like an array of these antennas, and it was like to test weather control essentially. But that's what sparked a lot of the conspiracy theories of like the government's controlling the weather. But like
okay.
they legitimately used it to control the weather, like experimentally.
Interesting.
I don't remember how they did it, but it had to do with cloud seeding.
Yeah.
But,
well, so that's the thing is like, of all the projects we've talked about, we know, like we have evidence that this works.
Yeah. Well,
go ahead.
Yeah. The Palo Verde power plant. Actually, so I got to do a tour there, and they said that because of the amount of water vapor that they give off just from the steam,
Mm-hmm.
Tucson, about 120 or 100 miles south of it, they actually cause it to rain in Tucson every now and then.
That's really cool.
Yeah, because the wind
carries that.
There's like a current that specifically crosses over them and goes down to Tucson, so they make it rain there a lot.
That's cool.
I thought that was really funny.
No, they make
Take
it rain.
that, Tucson.
Well, so like we have that example, but then we have so I read about there was a volcano eruption in the Philippines in 1991 that blocked, it was a huge, massive explosion, and ash was sent up into the atmosphere, and it lowered the temperature of the Earth by 0.5 degree.
Mount Pinatubo.
Yeah.
That's the one.
So yeah, you already knew about it, and you know about another one that was had an even greater effect. You want to talk about that one?
Yeah. Now I don't remember the name. Is it Krakatoa or something like that?
Yeah, I don't know how to pronounce it, but
it was
in 1816.
So I think the eruption happened in 1815, and
that makes sense. Yeah.
Yeah, I guess the energy output of this eruption was estimated at 3,000 times more than Mount St. Helens. And this actually took place a year before what was now, it's referred to as the summer, what was it? The year with no summer. That's what it was called, the year with no summer, because the following summer, it was so cold that as far south as New York, it was snowing in June. Excuse me, snowing in June. And there were areas of frost in the United States, like I think between Washington and New York, and kind of like the northeast area, there were frost areas that didn't melt at all the entire summer. And it's one of the
Dude.
coldest summers that we have on record. I think it was the coldest summer we have on record for civilization in the United States.
Oh man, that's so crazy to think about that. Like, so I lived in Alaska, and we didn't get snow in the summer, but we got like there were like giant piles of snow um at the end of May. Like
Wow.
it was so all the snow plows will deposit their snow to a certain area, and that mountain was still there like going into June. It was nuts.
But
And
that
so like,
happens in Flagstaff here in Arizona.
oh really?
And yeah, in May, sometimes you can still see like little patches of, I think, oh gosh, I thought it was like the last winter or the winter before that, it actually snowed at like the end of April
Wow.
in Flagstaff.
That's
But that's due to their elevation,
yeah,
like
yeah.
solely due to their
I can get
elevation at
that.
like 71 or 7,200 feet.
Yeah, that's crazy. So yeah, this cloud seeding idea, it works like very effectively. Um, it's just we need to when it's anything big projects, we need to get permission, and that permission's
Yeah.
never going to come. So,
Not
but
unless
like,
the humans die off first, and there won't be anyone to tell you no.
yeah. And so now that we've talked about kind of terraforming Earth, and we'll have a better idea of how easy it is to terraform Mars. And so these are some of the ideas that people have come up with for terraforming Mars. So NASA actually did a huge long study about kind of doing this. But if you melt the polar ice caps of Mars and like take advantage of all the water and all the gases and all of the soil, you could make let me start with this. The atmospheric pressure. So like the thing on Earth that keeps us like breathing and functioning and like being able to be outside, on Mars, it's 0.6% of what it is on Earth.
Essentially a vacuum,
Yeah.
like
And so,
comparatively.
no, totally. And so on Mars, if you were to melt all the ice caps and use all the water, all the gases, everything that was available in those ice caps, and a lot of the soil that you could get to, you would, they said in this study, you would effectively double the atmospheric pressure.
Huh.
So there's literally not enough water or resources on Mars to create the needed atmospheric pressure for humans to
What?
live.
1.2, that's a pretty big improvement.
Yeah, I mean, so, and they were saying there are certain species of plants and animals that could technically live in those conditions, but it's going to take a lot longer and a lot more resources for
Yeah.
humans to be able to live there.
Yeah, I feel like one of the big misconceptions about like terraforming that people um, like when they think of like if there's not enough air like available, like not enough atmospheric pressure on Mars, just put it there. But like you can't create something out of nothing.
Yeah.
So like it has to come from somewhere.
Mm-hmm.
You can't, and it certainly can't bring it from Earth. I would, if you thought the doing the 30 every 30 seconds a launch was tough, then yeah.
Yeah, that would be something else. I mean, I guess you just have to crash land all of your, like you just pump a rocket full of oxygen so much to where it like almost coalesces into liquid and then just crash it into Mars. But you'd still need like thousands of rockets.
Oh, probably hundreds of thousands,
Yeah.
millions.
Yeah. So the other idea is to not only bring more water and resources to Mars, but to warm up the atmosphere, is to send asteroids to it and just crash into it.
Wow.
Um,
That's even more ambitious than my project that I just thought of. Oh,
yeah.
how would that work? What would they
Well, I mean, so you only have to find an asteroid with a lot of water on it, and then it would take a while, but you could redirect it with rocket thrusts or whatnot.
so
And
then comets would be the target then, huh?
yeah, comets would be a huge, that would be a really, really good resource for if we wanted to crash it into Mars. But yeah, it's It's hard to like think you're gonna improve a planet by basically nuking it with asteroids.
Yeah. Doing to it the thing that Hollywood always portrays as what causes extinction.
Yeah,
The thing that's going to be our demise is what we use to save our lives.
yeah, yeah. The only thing that really seems like an option for us right now is to create biodomes on Mars.
I feel like honestly that would be my pick because one, it's way more practical, and two, you can do it a lot sooner than you
Mm-hmm.
could actually. Because if you can put everything into a dome, why would you need to go outside?
Yeah, like there's a really good series of books by Kim Stanley Robinson that if you haven't read, you should read it. I've mentioned it on the podcast before, but the first book is called Red Mars, the second book's called Blue Mars, the third book's called Green Mars. And so the first book talks about like initial geo engineering projects, and it is cool. And
Man,
like it took me a long time to read the book, or I listened to an audiobook of it, but it's a really good book, and it really dives into like the science of why things work and don't work and things like that. So it's
nice.
highly recommended.
Is this where our Audible plug goes?
I wish Audible was a sponsor, but we haven't quite gotten there yet.
Yeah.
If you haven't subscribed, subscribe or leave a review. But yeah, that's I would agree with you. It's the fastest, and like you can totally control all the variables inside of a biodome. And so like you don't need to go outside. You don't need to make
Yeah.
the entire planet habitable.
So if we did want to go the route of full on terraforming, are there enough resources like in Mars crust or under like deep inside for us to actually create that atmospheric pressure? Aside from even getting the right concentration of oxygen, nitrogen, and
Well,
carbon dioxide and all that stuff.
so because you're not going to be trying to create the atmospheric pressure of Earth on Mars for the whole planet, the polar ice caps would be more than enough to fuel multiple hundreds of biodomes.
Oh, I mean, aside from biodomes, like full terraform of Mars, like,
Oh,
is
I
that something that's been kind of just like, no, if we can't do it? Or is there still?
sorry, explain it
So,
again.
so I have a couple of, or there's a couple of problems I see as far as like full on terraforming, like the entirety of Mars to create like basically a second Earth. I'm sure like things that have been like looked at and addressed, but I haven't seen the answers. Maybe you through your
Well,
research have found something.
I didn't do any research about that specifically, but I just know from like past knowledge that it's it's going to be a very long time before Mars looks or feels anything like Earth,
Yeah.
if ever. Because like the one thing that gets me is I would rather colonize Venus than Mars. And the sole reason why is because the gravitational pull of the planets. Mars is gravity compared to Earth is 1/3. It's like 30%,
Yeah.
33% of gravity compared to Earth. 1 G on Earth is what we feel. On Mars, it's like 0.33 Gs.
Yeah. And
On
that's one
V
of the,
on Venus, it's 0.99 Gs.
yeah. However, it's the most toxic atmosphere in the solar system.
Also true, but there
And
is
well, because of how thick it is, how dense it is, it's also like the densest aside from the gas giants.
but that you see that as a problem. I see it as a solution. So we haven't been able to go to the surface of Venus for more than a few hours, but there's a um, NASA rover kind of project that's going to be happening of having a rover float on top of the atmosphere of Venus. And so I'm like, hey, if this atmosphere is so dense that we can't go into it for more than a few hours, let's create Cloud City from Star Wars on top of this thing. Am I
Oh, that
right?
would be amazing.
Plus,
Oh,
you
yeah,
don't
our
have to
own
do
Bespin.
yeah, and like the gravity is the same, so there's not like our body's going to be
Yeah.
deteriorating and stuff. And I don't know, it just seems like a much
So
cooler idea.
in regards to Mars and the gravity issue, that was one of my problems. Is that one, it doesn't have the gravity Earth has, but there's another thing that Earth has that Mars does not. That is almost more important.
A
The
magnetosphere.
magnetosphere, yeah,
Mm-hmm.
because solar winds. If you don't have a magnetosphere,
You're
The
toast.
solar winds are just going to blow everything away. If you even were able to get the stuff,
Yeah.
then you won't be able to hold on to it for long.
One of the cool ways that that Red Mars book gets around that idea of like no magnetosphere is they use the silica and the iron regolith on Mars to create these giant, super thick glass biodomes. And so
Ooh.
like they're partially transparent, but they have artificial lights inside. So it's like there is light coming, but because Mars is farther from the sun, they don't get as much light as Earth, and so they just automatically have to do artificial
So
light.
we can go to Mars just to have our own version of the Truman Show.
Yeah, exactly.
Can we send Jim Carrey there
Oh
and have the
man,
whole package?
I wish that'd be so cool. And just
Um,
have like a recreation of the Truman Show on Mars.
so it sounds like full on terraforming is not an option, and
It
instead it would
just,
be biodomes on
yeah,
Mars. Would that mean that the exterior of the biodomes is going to have, and is it going to be the same as Mars looks now, or is there going to be any other kind of resemblance as far as the effect of terraforming? Would terraforming be restrained to within the domes? Essentially, is my, I guess, the
I
short
honestly
version.
think that it's going to be a tandem thing. They're going to be
Yeah,
biodome cities. Like there's just going to be these giant cities of biodomes and tubes, and like people are saying we should go underground as well to mine Mars resources and create like safety from the magnetosphere or from the solar radiation. But I think that at the same time they're doing biodomes, we're going to do what humans do best. We're going to warm up the planet to where it's almost too hot to live. And right now, Mars is super cold. So
yeah.
we'll just go there and do our thing for a little while and warm it up.
So outside of the biodomes, there will be no terraforming. There will be no likeness of
I
Earth.
I don't think that there's going to be any likeness of Earth in several lifetimes, but I do think that there will come a time when it won't be as red. I think that there will be oceans. I think that there might be some plants and some animals because there are
Certain
animals
things
that,
that
yeah, I think
can grow in there.
there's some animals that can live in those kinds of situations, but I still don't know about the radiation.
It's just be a
That's
world
the
of
wild card.
tardigrades,
Yeah.
water bears everywhere.
Yeah. So yeah, I didn't realize how long we're going. I kind of want
Nah.
to talk about the ethics of terraforming, both on Mars and on Earth, um, just to wrap things up.
Okay.
So one of the things that people say we shouldn't mess with terraforming because we don't we don't know the consequences of our actions. And so before I give my opinion on that, what do you think about that?
Well, and take AI for example. I mean, that's, I feel like, a lot more imminent than a lot of the other, like as far as global warming. I feel like if if global warming does take, or I guess climate change, I'll call it, because I'll be PC on it. So climate change is any kind of change that's significant enough to alter the way we live or influence the population on Earth. I feel like is going to be much further in the future than a similar effect from AI. And even Elon Musk himself says that he believes that the first human death or even murder, I think he might have said, at the hands of AI on its own accord, not just being like a line of code that was written, but like machine learning that taught itself and chose to do that, will happen before we have any regulations in place to prevent it, any kind of laws. So
Isn't that how it always happens though? Like something
yeah,
bad happens and we're
and
like, oh,
then you
we want
create
to,
a law.
yeah, we want to prevent this from happening in the future. And that's when a
Yeah,
law gets
we're
made.
very nearsighted in that aspect. And I
Agreed.
think that's where the negativity of innovation kind of creeps in, because you have, like, this thing is incredible. This phone, there's more processing power in my watch than there would be on, than there was on all of the Apollo missions combined for
Yeah.
their landers. Like, it's incredible what we figured out to do, but it comes with the negatives, because one, it lets it, I mean, okay, positive, I get to do the Zoom call right now. Without that, like, schools, they'd be screwed.
Yeah.
Like, but also with it, like, we're going to have um, issues with probably our vision over time.
Hmm.
We're going to have issues with circadian rhythm because people can't sleep at night because they want to watch TV instead.
Yeah.
And those are just the minor things
Well,
that kind
even
of stack
I'll
up.
I'll share a good example of what you're talking about. So my dad's in the military, and he talked about how the technology that we as scientists and engineers make, we don't always think of the consequences. And so he was talking about how in Afghanistan, the extremist groups over there were using drones to put explosives on and fly them into the barracks and into the camps of American soldiers. So they don't even have to like be using their own people or using cars or anything like
Yeah,
that. It can just happen at any time. And so it's crazy to think that like drones are so cool and they've given us this new perspective and new hobbies and other things, but there's also this dark side to them of like they can be used to surveil people. They can be
yeah,
used for, to plant explosives and things like that.
exactly. Because why have a land invasion if you can push a button and be done?
Hmm. Yeah.
Nuclear warfare. We have nuclear powered things like the Palo Verde plant. Without that, then a very large portion of Arizona, Texas, Utah, Colorado, and California would not have power.
Yeah.
But because of the same technology, because we figured out how to use, can't remember what kind of uranium it was, to I don't know,
Was it 235?
to something like that, can also be weaponized. So yeah, like things like that. I mean, those are immediate examples, things happening right now of how, our intention for good can also be, it can create a problem bigger than the one that we solved in creating it.
So do you think that that should stop innovation? Do you think that like because we don't know the consequences, we should just not touch this at all?
Absolutely not. Um, but what I do think is that it's we have to come up with a system that allows us to be more mindful of what we do.
Hmm.
Um, and perhaps AI will allow us to do that. And if it does, then that's fantastic. But we need to get we need to get our act together as a
I
human
no, I totally
race.
agree. I think it's interesting that people are avoiding developing something or avoiding something because they don't understand it. Like
Right.
this AI thing, people are afraid of it because of what they see in movies, but they don't understand like yes, there are bad things that could happen, but there's also tremendous good things that could happen.
And here's the thing: the industrial revolution happened what, like 120 or so 140 or so years ago, like
Yeah,
what,
give or
late
take.
turn of the century, 18 to 1900s. Um, we are currently feeling the effects of the start of that,
Hmm.
um, and also the effects of present day. But a lot of what we have now, we didn't know until more than 100 years after it started.
Yeah.
Right now, we're coming up with solutions for those things: electric cars, those scrubbers, and what was it? Switzerland,
Switzerland. Yeah.
Switzerland. Like, we're coming up with solutions for that, but in 100 years from now, will we look back and be like, crap, we should not have made electric cars? Like, is that going to happen? In the same way that, like, man, we should have been more mindful during the Industrial Revolution. Are we going to come across the same kind of like creation, then like, oh crap, regret?
But I don't think that we'll eventually think of those kinds of things. That's hard to, I'm not expressing myself
I'm
well.
not against electric cars, by the way. I'm
Oh,
100% for them, but
electric cars are the only way to go.
especially because of the Industrial Revolution.
Yeah. Fun fact within the fun facts, the first car ever made by Ford was an electric car.
Yeah, actually, I remember reading about that because the first cars were electric, but the reason they never caught on was because, one, their distance, their range was terrible, and then also the ability to recharge them was like ridiculously difficult and took
Yeah.
forever.
Well,
No one wanted it. It didn't have any appeal to it.
well, the reason they were a thing in the first place was that they hadn't gotten internal combustion down yet,
Yeah, they couldn't
and
figure
so
that out. Yeah,
yeah. So fun fact. But I'm glad that that was a really good discussion. I liked that. Like, just because we don't know the consequences doesn't mean we shouldn't pursue something, but we also need to make sure that we can be prepared for the
exactly.
consequences.
Preparation,
Yeah.
preparation from ourselves.
Well, and to think about it now is we have more foresight in the things that we do now than we did 100 years ago.
Yeah,
Like,
because
if you, I don't know if you know this, but like in the 1920s, 1930s, there were doctors prescribing cocaine to children for toothaches.
mhm,
That I it doesn't make sense that that was the thing. But now we know the consequences. We have more foresight
right,
into the technology. We have testing. We have so many different things that help us understand the consequences
right.
that
Because without the innovation, we also wouldn't know the consequences.
yeah.
And if we're able to get a hold of those consequences, then we've we've improved.
Hmm.
Like, I wouldn't say I wish we never innovated, because what would we be today if we did not? How would
Uh,
medical practice, would it even exist? Would there
yeah.
be medicine? Because we wouldn't understand that. Like, communication, there wouldn't be language if we didn't create one.
Yeah.
So yeah, like, innovation is good. It comes with its negatives, and innovation might be what ultimately causes us to be extinct, but like,
Well, I think after a
live
certain
happy.
point, yeah, after a certain point of innovation, we'll be able to foresee
Yeah.
any species ending events and be able to rectify them.
And what fun is life without a challenge? We're just giving our
Absolutely.
grandchildren something to look forward to.
Yeah, that's one way of saying it.
So they can
Um,
fix what we did.
yeah, we'll just kick the bucket down. So another ethics standing point for specifically Mars is if we go there and we put our germs and our experiments and our people down there, we're destroying any potential life that could be there.
Exactly. And actually, I was going to bring that up earlier, but I didn't, because I was wondering if you might. Um, that
So
actually is one of the top debates right now, is like,
yeah,
especially, yeah, I can't talk, especially when we send rovers. Like, they're, first of all, they're manufactured in a clean room for like static discharge
yeah,
reasons, and then just the protection of the equipment in general, but also they're like full on sterilized, like hardcore
yep,
sterilized before launch. Because if even one Earth bacteria made it onto Mars, we have no idea what that would mean. Same thing for the moon. Like,
hmm,
there could be tardigrades on the moon and we don't know it because
yeah,
of the space race, and we were so desperate to get there. If you've ever like read a book about the the engineers who like designed everything for the launches, and for the Apollo missions, like, I'm surprised it worked at all, any of them, let alone
yeah.
like all of them, and that we even brought back Apollo 13. Like, I'm blown away that nothing failed because of how it's like, you know, duct tape that
Saved
like
them.
saved them.
See,
It's just nuts.
what boggles my mind even more than what you're saying is the fact that we were able to do that and then we just stagnated for like 30 years. We just did
Yeah.
nothing.
Because we had no reason to go back. Come on.
What a dumb reason.
Plenty of reason to go back. Send the
So,
people there who said that.
yeah. Now, so this is the last reason for ethics that's kind of interesting to me because I definitely agree with this. This is a reason why we shouldn't go and terraform Mars. Is wherever humanity goes on Earth, we pollute and we destroy. Like, like 9 times out of 10, I'm just throwing that out there. We go somewhere, we take advantage of the resources, we destroy it, and we ruin it. And so by going to Mars and like starting over, we're not fixing the habits of our society, our global society. We're just going to be just as destructive and just as pollutive as we are now if we don't fix the problems now
Mhm.
and fix our behavior now.
And on top of that, it'll be an expedited process because here on Earth, we didn't start out as like these greedy people. Like we became that. And if we go to Mars, we are going to start out as consumers, as capitalists.
Oh, see,
And it's going to happen right away.
I think
It's
I
not
did.
going to take time.
I disagree with you a little bit. I think the natural part of our brain, we are greedy. That like long time ago when we were just developing, it was me first. If it's not me first, I'm gonna
Yeah.
die. And we're still
Greed.
in that
Yes.
mindset.
Okay.
We're not thinking about others. Like this whole mask debate, I'm just like, is it really this hard? And it's just like it's not. It's the mask isn't for you. The mask is for everyone else.
Yeah. It's not for the person wearing it.
And so I'm like, I just wear it to protect
Yeah.
someone else. That like, sure, it's not that deadly, but it's a nightmare. I get so anxious when I'm like going to hang out with someone. I'm like, where have you been? What have you been doing? Who have you talked to? You know what I mean? Like
Yeah.
I have this 1-year-old almost that I'm trying really hard to protect, and I don't know. It's just it's
I'm on the same
interesting that
boat.
I forgot we
Yeah.
to tell everyone that we both are in the same boat as Hayden. All three of us are new dads, kind of experiencing this.
Hey, I didn't know that about Hayden. That's
Yeah,
awesome. Congrats,
yeah,
Hayden, if you're
yeah.
watching this.
Hayden, he had his little boy in November,
Dude,
I
so
believe.
we were all like, what, about 6 months apart total?
Yeah, yeah.
'Cause, mine was April and yours was a couple months after
September,
that?
September. Yeah.
September. And dude,
Hayden's might
we're
have
all
been
gonna have,
in. Hayden's might have been in October, maybe. I think it was
okay,
November though.
nice. Dude, that's awesome.
But yeah, it's so weird to me to think that like people, the general populace, which is fine, it's just where we're at right now, but the general populace is me first.
Hmm. I guess I
And
misspoke when I said greedy. I meant, yeah, okay, we've always been greedy. I guess we're just more effective consumers now.
yes, agreed with,
Back
yeah.
then, it would have taken a very, very long time to use up the same amount of resources that one person will use up in a day here.
Absolutely.
So by that means, it's especially since Mars is smaller, there's going to be less room for that, and we're going there prepared to already be, you know, consuming and capitalizing
Yep.
probably even greater than we are now. Or we're going to be more resourceful, probably figure out how to reuse a lot of stuff. But I mean, there's already like
That's a good point.
most the downside to like, the private sector taking kind of the reins on this now is the private sector is run by a lot of very strong um, capitalist minds. So if they can,
Yes.
there've been lots of talks about like mining Mars and then bringing resources back here, because there are a lot more asteroid impacts there. There's a thinner atmosphere, so things like iridium will be a lot more available. They could bring it back here.
It's funny that you mentioned
Expensive.
that. So like the Red Mars book that I keep mentioning, they talk about how one of the first missions of them settling Mars is to mine it and send resources back to Earth. And if you want to read the book, stop listening. But spoilers, they end up deciding as a colony on their way to Mars. They haven't even gotten there yet, but they've decided in the spaceship going there. This happens early in the book anyway. They are not going to do that.
Huh.
It's more effective for them to use the resources they mine to build the colony that's going to be theirs.
Yeah.
And
Sorry,
so,
I think I had a power surge a moment ago. I don't know if you saw the flicker of my lights.
no, I didn't.
I don't know how my internet's still up. This happens like a couple times a week, but I digress.
Well, that's good.
Yeah.
But yeah, anyway, if we are going to do the whole Mars colony thing, I think we need to fix our habits that we
You get
have
one
here on Earth.
chance.
Yeah.
Like we get a do-over. If we get a do-over, then fantastic. But we can't just be like, oh cool, do-over, let's go.
Yeah.
Like we've got to go in with the plan. We've got to go in with restrictions
And it's got
and
to be smart
moderation
and
too.
absolutely, absolutely. And so, yeah, that's our terraforming episode. I hope you guys listening got something out of this and were able to learn something, dropping some knowledge bombs,
I
as
learned
we
something.
would say.
I learned a lot.
That's good. Any final thoughts, Micah?
Oh, send me to Mars. There we go.
You'll
Um,
be one of the scientists making sure we do it right.
here, I'll be one of the guys helping build the rocket, and then I'll be one of the guys that gets on the rocket after it's built.
Yeah, just kind of sneaking aboard.
Stowaway. I did it like in what is it? Firefly.
Oh, I
You
haven't
seen
seen
that
that.
show? Oh,
It's on my list.
best show ever to get canceled.
I'm about to finish The Expanse.
Okay.
So I'm very proud of myself that I've seen that. I've heard so many people talk about it, and it's solid.
Nice.
But so usually, I forgot to mention this to you, but usually when we wrap up our podcast, we have like a recommendation little part. So like this week, just for example, and this is my recommendation to everybody. I've been watching a lot of a YouTube channel called Smarter Every Day.
Oh,
This
best
guy's
channel
like,
ever.
he's my hero. And it's Adam Savage, Mark Rober, and Destin Sandlin. He's the Smarter
Yeah.
Everyday guy. If I could
he
meet
was
those,
NASA engineer.
yeah. Wait, Mark Rober was the NASA engineer.
So Destin too, because he helped design the drill on Curiosity. I thought.
Oh, I remember
he
that
had a part
video,
in
but
that.
I don't remember him saying he was a NASA engineer, because I
Maybe
always
he
thought
wasn't a NASA engineer, but he had a part in designing the drill for.
Oh, I'm gonna have to go
I thought
rewatch
he
it now.
did.
I'm gonna go rewatch it just to be clear.
Okay, I know there's an episode about it.
Yeah,
Don't take my word for it.
I'm gonna rewatch it and I'll text you and see what happens.
See
But
who's
anyway,
right.
that's something that I've been doing this week, and I always watch Mark Rober, but I've already recommended him, so I figured I watch him and Smarter Every Day almost every week. But yeah, that's my recommendation. I don't know,
Okay.
Micah, I'm kind of putting you on the spot, but is there anything this week that either you watched, you listened to, or you read that you could recommend to our listeners?
It's not from this week. It's a book I actually read 2 summers ago, but I had just restarted this past summer. It's a very good book. Let me pull up the name. It's a long name, but it explains very, very well climate change, and it's an incredibly convincing account.
Yeah.
It's
you got it.
Go ahead and do your thing.
Okay. So while he's looking that up, I am still 3D printing the replica of the Perseverance rover that is on its way currently to Mars. And this replica will be given out as a giveaway. And so I don't know exactly how we're going to operate or do this giveaway, but I am excited to do this. I'm actually jealous that I don't get to keep it and like kind of,
enter the giveaway yourself.
Yeah.
And then,
but I figured it's one of those cool things to kind of, it helps someone and it helps us kind of get our podcast a little bit more people listening. So I'll make sure and finish that print, and I'll send some pictures over our social media and the conditions of the giveaway. So be on the lookout for that.
Right on. All right, so I've got two recommendations now.
Ooh,
because I
double
had time to think about
recommendation.
it.
Yeah.
First one is this book called Antarctica: An Intimate Portrait of a Mysterious Continent. Wow. And it's by I believe she was a journalist, or is still a journalist, Gabrielle Walker, and she goes to all the different major research stations on Antarctica, and she spends like a week or so at a time with certain scientists, and then asks them questions, sees what they do, follows them around, and it's just like her personal account of this. But the research they're doing it's not just like they're going there and like, oh, look, let's look at Antarctica. No, they're like doing very specific research, and almost all is about climate change. And there's some very terrifying things that they're discovering, especially in regards to things like the Ross Ice Shelf. So I highly, highly recommend that book. I couldn't put it down. Here's the other one. And we had talked about this earlier. Every Tool is a Hammer is one of my favorite books of all time.
Yeah, by
written
Adam
by Adam
Savage.
Savage. Adam Savage is the reason I am where I am today, as far as, physics and engineering. I would probably be stuck in a really crappy job and not caring about science if it were not for him. So I credit him with almost all of my excitement and motivation in regards to science.
No, I definitely love the enthusiasm he has for making and for science and for engineering, because I don't know about you, but I watch religiously all of his build videos. He does
Did you
them
watch his apron one that he did like yesterday?
Yes.
Oh, that was probably the most satisfying one I've ever seen.
So what's funny is because they come out in the mornings, and I usually on Thursday, Friday, Saturday I don't have school or work. And so I'm watching my son, and my son has gotten so used to his voice that he will sit there as an 11-month-old. Sorry, I do that all the time. As an 11-month-old child, he'll sit there and watch with me. It's hilarious.
That's exciting.
And I'm so glad I get to share it with him. But yeah,
Still
I'll make
that
sure.
same curiosity.
Yes, I want him to be so curious and be able to foster that curiosity and stuff like that. So I'll make sure and tag Adam Savage. Maybe he'll retweet us again.
That'd be awesome.
But yeah, thanks for coming on.
Yep.
We'll definitely have you on again.
Thanks for having me.
Yeah, and as Hayden would say, we'll catch you on the next one.